Welcome to Sis Jensen Info Center. Today we'll talk about oil maintenance within mining applications. The main focus will be on how to reduce machine breakdowns with oil filtration. We'll talk about different contamination in applications and different filter technologies that will help you. Machine breakdowns within mining applications are very expensive, and most of the processes relate to each other. So if we look at the cost related to breakdowns, the majority is actually due to downtime, often 85% of the cost. A typical maintenance budget may have 3 to 5% related to the oil, but the failures that are related to oil are the majority of the failures. So this study concludes that by training and best practices within oil maintenance, you can actually avoid 70% of the breakdowns and thereby avoiding expensive downtime. It's not uncommon practice to only perform a repair on a machine in mining applications when they have had a complete breakdown. This reactive strategy is very expensive because you have implications after the repair and also because the unscheduled downtime will mean lost production. So many mines strive to use a preventive maintenance strategy where they replace oil and parts according to a set time interval. This may still be costly because the parts that are changed may not need to be, and also because even though it's planned, the downtime is still meaning lost production. So from an OPEX point of view, the cheapest way to maintain, for example, a crusher would be to run proactive maintenance. That means using predictive oil analysis to monitor the oil cleanliness, also remove the sources for the failures. That will mean, for example, dust coming into the oil system, and remove it as soon as possible. So an offline filter would be part of the defensive machine design, prolonging the life of the oil and the parts. So the worst particles in an oil would be hard abrasive particles that are in the clearance size. They are wedged between the moving parts and will create a lot of additional wear. Here is an example of a contaminated oil with particles and varnish. Oil degradation is when oil is having some catalysts in it. That could be wear metals, water, or high temperature. This degrades the oil, creates a varnish sticky layer that may cause a malfunction of a valve. When water is present in oil, it cannot withstand the high pressure, so the water droplets will collapse or implode, and they will create cracks in the metal and release a lot of particles. Cavitation is when water is present in oil on the suction side of a pump. The water will turn into vapor, and inside the pump the vapor will collapse or implode and causes cavitation that destroys the pump. This table shows cleanliness recommendations to different machine types. And it's quite common within mining applications to see very contaminated oil with ISO codes in the 20s and the red area here meaning reduction of the lifetime. If you, on the other hand, clean the oil to a lower ISO code, you will see a longer component life, longer oil life, and will be minimizing the downtime. If we look at the distribution curve for particles within used oil, you'll see that roughly 70% of the particles are smaller than 5 micron. This is because smaller particles are being created when larger particles are getting crushed, and also because the tinier particles are very difficult to capture in the normal filters. About 10% of the particles are bigger than 10 micron, which means 90% are smaller than 10 micron. Standard inline filters within mining applications are typically 15 to 50 micron ratings. That means some filter life, but also wear, because the clearance size particles are not being removed. If you, on the other hand, had a 3 micron rated filter in the same size, it would only last very few operational hours, because now it needs to take out 60 to 70% of the particles instead of previously a few percent, of the particles if you only look at 15-20 micron and larger. This is why we have different filter technologies. The inline filters are designed for the high flow rate and high pressure coming over the filter at a low pressure drop as possible. This is why it's made of thin sheets of filter material. The whole volume of the oil system may pass the inline oil filter in just a matter of few minutes. The offline filter is designed to slowly circulate the oil volume over the filter, maybe 3 hours to circulate the volume of a crusher gearbox. The finer filtration and the slower continuous pace means that you'll be able to take out more contamination and also water and varnish, which will prolong the life of the oil and the components as well. The offline depth filter is designed as a maze or a labyrinth that has much more room for contaminants compared to a pleated filter, often 40 times higher. If we look at the cost for removing 1 kilogram or 1 pound of particles from oil, you will see that a depth filter with a large dirt hole capacity will always win. In this example, the offline cellulose filter costs 4 times more than the pleated filter, but since it has a dirt hole capacity of 4,000 grams compared to 100 grams, it will cost 1/10 to remove 1 kilogram using an offline depth filter compared to a pleated filter. So what will clean oil give you? You'll increase the reliability and profitability of the mine by having longer life on the oil and the wear parts and reduce the downtime. You will be able to reduce 75% of the oil changes. For example, every 1 year instead of every 3 months oil change on a crusher and mill. That is good for the OPEX and also for the environment. You'll be able to decrease downtime by 75%, and this is where the real savings can be found. So increasing reliability and minimizing downtime. And finally, reducing the spare part consumption by 60%. That means longer life for mechanical wear parts like bearings, gears, valves, etc. Will give you a more reliable operation. Thank you very much for watching. If you want to learn more or for support, go to your nearest Jensen contact at cjc.dk/contact.